I'm Shayna and we're in Geography 203.
Today we have a couple simple experiments to demonstrate a few concepts in meteorology. So our first experiment is called the crumple can experiment, and it's to demonstrate pressure and different changes in pressure. So first we have a regular aluminum can, Diet Coke, and we have a hot plate and a bath of cold water along with tongs and a spoon. So first off, we will begin with heating this up, putting water in the can, letting it heat totally, completely, transferring it with the tongs to the bath of cold water, and we'll see what happens. So now that we've added the spoonful of water into the can and it's fully heated, we're going to flip it over right into the cold bath of water. So here we go. So there's our crumpled can. The reason it crumples at first is because aluminum is such a thin and flimsy material that it can't withstand the pressure difference immediately. So basically the more scientific reason as to why the can popped and scared me to death was because first of all, the water in here had been really warm, so it had been heated up from this, so there's hot water vapor going on here. So the temperature was hotter here, however the pressure was still exactly the same between the surrounding air and the air inside here, as well as in the cold water. So we took it here, flipped it upside down, and the warm water condensed so quickly and the pressure dropped so drastically that in order to compensate for this pressure differential, the can crumpled and thereby reduced the volume and tried to equalize the pressure. So how this experiment relates to the atmosphere is that everything we're used to, so weather, wind, and ocean currents, are all driven by pressure.
Our next experiment is to demonstrate air pressure in the atmosphere. So we're going to give you a little visual here. We're going to start off with a candle, some food color, a plate, dyed water, and a cup. So we're going to start with, we're going to light the candle. I'm going to pour some water on the plate. And we're going to put the cup over top of it. And the flame is eventually going to burn out. And watch as the water gets sucked up higher to equalize the pressure inside the cup. Eventually all the water is going to go up in it. And it just equalized the pressure inside of the cup. And this relates to the atmosphere because when we measure the air pressure at the surface of the earth, we're measuring how much air is above us. So if air pressure falls, there is less air above us, and if the air pressure rises, there's more air above us. The relationship between the temperature and the pressure is very important. As the temperature falls, so does the pressure, and the temperature rises, and so does the pressure. This means that as air moves up in the atmosphere and the pressure falls, temperature has to fall as well.
So for our third experiment, we're showing the process of cloud formation and all the different factors involved in creating a cloud. So it's a super simple experiment. We just have matches and a 1 liter bottle, and we're just going to add a couple drops of hot water. So we're adding the water, putting on the lid, squeezing it a couple times. If you squeeze it, the pressure's increased, the temperature increases slightly inside. Squeezing, squeezing, squeezing the bottle, nothing's happening. It's because we're lacking condensation nuclei. So in the atmosphere, that would be things like dust or smoke. And in our next step, we're going to actually introduce some condensation nuclei and show you what happens.
So for our next step, we're going to light the match. Blow it out. Put the steam in the bottle. Where's the cap? Okay. And then we're going to squeeze the bottle a bunch, build up the pressure inside. And we're going to hold it there. And then I'm going to release the bottle quickly.
And it's hard to see, but some condensation has formed in the bottle up here, and we have kind of a light mist of clouds on the inside.
We hope you enjoyed our experiments.
And hopefully learned a little something about the atmosphere too.